Astronomers tracking 3I Atlas say it has altered its course, worrying scientists about its close proximity to Earth.
Harvard astrophysicist Avi Loeb has suggested the 3I Atlas is actually some type of alien technology.
3I Atlas is coming and the date is now set in stone. October 3rd, 2025. The day this green interstellar traveler makes its closest brush with Mars before slicing toward the Sun on a one-way trip. There is no quiet lead-up. We're already inside the event. NASA's alert boards are glowing. Observation schedules are being torn apart and rewritten. Telescopes across the globe are racing to catch as many photons as possible before the comet vanishes into solar glare. Out beyond Mars, a visitor from another star is moving so fast it could cross the Earth-Moon gap in just over an hour, a speed no human probe could ever hope to match. Its discovery didn't make headlines at first. On July 1st, 2025, the Atlas survey in Chile recorded a faint object sliding through a star field. Orbit calculators struggled. Every fit broke apart. Every solution refused to loop until the data converged on something extraordinary. The orbit wasn't closed. Its trajectory was hyperbolic. That meant this was no member of our solar system. It wasn't bound to the Sun. It was a wanderer, just passing through. Then came the night the sky announced its arrival. September 7th, Earth turned its face toward a total lunar eclipse. The moon, painted a deep crimson, glowed against a darkened sky. Amateur astronomers stayed up to capture the spectacle. One of them noticed a faint bluish smear in the frame. Hours later, from the other side of the world, another image appeared. Same object, now haloed in an unearthly green. By morning, confirmations were streaming in from 3 continents. The glow didn't fade when the eclipse ended. It held steady, as though the comet had been lit like a signal flare. The designation followed quickly. 3I Atlas. The I meant interstellar, marking it as only the 3rd such object ever confirmed. The first was the enigmatic shard Oumuamua in 2017, spinning in a way no model could quite explain. The second was Borisov in 2019, an icy comet that looked familiar, but spoke with the chemistry of another star. And now, Atlas. Its coma was swelling night by night, its tail lengthening, its brightness climbing as sunlight woke it up too quickly. Astronomers know green comets well. Their color usually comes from dicarbon molecules near the nucleus. When sunlight strikes, the C2 swan bands light up the spectrum. But when spectrographs targeted Atlas, those lines were missing. No C2 signature. The green was real, but it wasn't from the usual source. Infrared instruments added more mystery. Instead of water dominating the gas output, as is almost always the case, carbon dioxide was in the lead. 8 parts CO2 for every part H2O. Cyanogen was there. Carbonyl sulfide whispered in trace amounts. Carbon monoxide was faint. But nothing in the chemistry explained that violent emerald glow. It was like finding a bonfire that burned on dry ice. Then came the result that turned heads everywhere. Nickel lines, more than 20 of them, lit up the spectra, some even blazing in the ultraviolet, while iron was barely visible. Normally, nickel and iron travel together, locked in the same dust grains. Atlas had split them apart. The best explanation pointed to volatile nickel-carbon compounds that release easily under sunlight, leaving iron trapped in tougher minerals. If true, Atlas formed in a star system's cold outer reaches, far beyond the warmth that would have melted those compounds. It may have been sitting in deep freeze for billions of years before a gravitational nudge sent it on this one and only journey through our sky. Suddenly, this wasn't just another comet. It was a message from before the birth of our sun, carrying material frozen since the earliest age of planet formation. Observatories scrambled to get as much data as possible, but time was running short. As Atlas drew closer to the sun, the viewing window began to close. Hubble and the James Webb Space Telescope have strict solar keep-out zones to protect their optics. By late October, both would be forced to look away. Inside time allocation committees, arguments broke out. Could they bend the rules for a once-in-a-generation target, risk the hardware to keep watching? In the end, safety protocols won. The flagships would go dark during the most revealing part of Atlas's passage. That left Mars to take over. Its orbit trailed just inside the comet's path, perfectly placed for a close look. Teams running the Mars Reconnaissance Orbiter and MAVEN retasked their instruments, squeezed in target of opportunity slots, and flipped pointing plans overnight. For a few crucial days in early October, Mars would become our outpost, the only place with a clear line of sight. And then, the humbling discovery. Atlas had already been here, at least in our cameras, before anyone noticed. In late 2023, NASA's TESS mission caught it as a faint moving dot while scanning for exoplanets. But the pipeline, tuned for periodic dips in starlight, ignored it. In 2024, the Vera Rubin Observatory, still running test surveys, recorded it again. The data sat buried until July's discovery sent astronomers back through the archives. Frame by frame, they traced its path, realizing how close we came to missing it entirely. That near miss has already changed the playbook. Rubin's software is being upgraded to flag hyperbolic trajectories and strange colors instantly, so that the next interstellar visitor is discovered in near real time. The age of lucky finds is ending. The era of constant vigilance has begun. But discovery alone is not enough. These visitors are too fast for traditional missions. Engineers are now sketching rapid response interceptors, small modular spacecraft that can wait on the ground until the alert comes. Solar sail flyers that can pivot toward a target. Instrument packages that can snap together for different science goals. Swarms of microprobes that can flank a comet and map it in 3D. The goal is simple. Stop losing these messengers to time. Because Atlas won't slow down. After the Mars encounter on October 3rd, it keeps accelerating, reaching nearly 98 kilometers per second by perihelion on October 29th. It will blaze under the sun's light one last time before fading, disappearing into interstellar space forever. Its green glow may never be fully explained. Maybe a radical we have never catalogued. Maybe nickel chemistry that only happens in ultra-cold star nurseries. Maybe a process no one has ever seen. Whatever the answer, Atlas has already left its mark. The first messenger, Oumuamua, spun like a cosmic riddle. The second, Borisov, looked like a normal comet but carried a chemistry that didn't match our own. Now Atlas burns a color we can't explain with molecules we thought we understood. There will be no encore. No second orbit, no chance to try again. One pass, one window. If we are ready, we read the message. If not, we watch it fade and wonder what secret we let slip through our fingers. As Atlas makes its sprint past Mars and curves toward the sun, the question is no longer whether we will see it. We already have.